Okay, our next lesson we're going to look at logarithm graphs again, but now we're going to deal with our transformations just like we did before. We're going to have vertical and horizontal stretches, reflections, translations up, down, left, right, those types of things. So here's our regular log graph. So this is y equals log x. Remember that's base 10. So that means our graph would start at 1 and then we'd have 10 to the power of 1. So we'd go over to 10 and up to 1. So you can see there. That's typically all we want to do when we graph these things. So if I gave you y equals log base 3, it'd cross through the same 1, and then we'd go over to 3 and up to 1, so that our graph would be a little bit steeper, something like that. Okay, so you can see in our original log 10 of x, you can see it's been translated over. It's just been shifted over 3 spots. So we'd write it as log x minus 3. So a lot of our translation rules are going to be exactly the same. So here's our sort of our generic formula. So we have an a value in front. So just like before, that will be our vertical stretch. And if it was a negative, that would be a vertical reflection. The c is just telling us what kind of graph it is, log base 2, log base 3, whatever. So the c doesn't mean anything. Our b value is our horizontal stretch and reflection if it's negative again. But remember, we also got to do 1 over b, just like we do for every other graph. Our h, being with the x, is our left-right, and it's opposite of whatever the sign is. And our last one, the k, is our up or down. So let's go through this one. So we've got our original. So let's actually sketch this as we kind of go through this. So our regular y equals log 4. So it should be through 1, 0, and then we go over 4 and up 1. So that would be our regular log graph, something like that. So now let's do all of our transformations. So we've got a plus 4, so that means we're going 4 to the left, and then we got 5 down. So all we have to do is basically just work with those two coordinates. That's the easiest way to go. And we also know that we have our asymptote line would be at the 0, the y-axis. So if we go 4 left, our asymptote line would now be at negative 4. And then let's just move each of these points. So if we go 4 left, 1, 2, 3, 4, and we go 5 down, so that first coordinate would be something like that. Take our second coordinate, go 4 left, 1, 2, 3, 4, and 5 down, 1, 2, 3, 4, 5. It's going to be something like that. So our graph would be something like that. So there's our new graph. So our domain originally was x is greater than 0, so now it'll become x is greater than minus 4 because we moved it 4 left. Our range is still YER, that doesn't change. Our intercepts have changed. So originally we had no y-intercept. You can see now it's down at negative 4. And our x-intercept was originally at 1, but we've moved it over, so it's going to be somewhere over there. So we don't really need to know what the intercepts are. We could figure it out from a graph. We could just graph it and check it out that way. But we do see that they have moved. And our asymptote, obviously, we went 4 left, so it's at negative 4 now. So there's our graph. This last part, x, y, remember that's just saying what are we actually doing to every coordinate. So we're moving 4 left, so we're taking our x value, subtracting 4. We're moving 5 down, so we're subtracting our y value by 5. Okay, so let's do a couple more. Let's sketch these and figure out any invariant points. So let's once again our regular graph y equals log 9. So if we graph 9, so our originally would be at 1, 0, our other one would be at 9, 1. So that would be our original graph. The 2, all that's going to do is make it twice as tall. So our original coordinate that's at the 0 line is also going to stay there. 2 times 0 is still that. And then our other one will go from 1 up to 2. So a 2 times vertical stretch would just do something like that. My point's a bit off, but you get the idea. Okay. So in this case, our invariant point is that 1, 0. Doesn't change. Every other coordinate would be double the height or whatever. But because it's 0, it's obviously going to stay the same. Okay, let's graph the next one. We got log base 2. So we're going to have our 1, 0, and we're going to have 2, 1. So our graph would look something like that. So in this case, The negative is going to make it go upside down, so that coordinate's going to flip upside down. So it'd be something like that. And then the other part is the 4. Remember, that's going to be a 1/4 horizontal. So that means those coordinates are going to go a quarter of the space over. So that one would be at a quarter, and the one that's at 2 is going to be at a half. So our graph would end up being quite skinny. So something like that. Okay, so a vertical reflection and then a 1/4 horizontal. So in this case, we have no invariant points. Okay, so you get the idea in terms of reflections. So let's do this one. It has a little bit of everything. So let's sketch it again. So our base graph is log base 3. So that means we'd have our 1 point there. The other one would be at 3, 1. So our original graph will be something like that. And now let's do our transformations. So the -2 would be flipped. So let's do your stretches and reflections first. So they'll be flipped and twice as tall. So our 1, 0 stay the same. We'd go upside down and then double it. So it's going to go to something like that. So that would be our double and flipped. And then we've got 3 to the right and 5 up. So just take each of those coordinates, move them 3 over and 5 up. So this one's going to move way up here, and this other coordinate that was down there, we're going to go 3 over and 5 up. So this one was down at -2. So 1, 2, 3, 4, 5 will be up to +3. So 3 over, 5 up would be somewhere about there. And that's it. So our new graph then would be something like that. Okay, so just like we do any other kind of transformation, always do your reflections and stretches first, then do your left, right, up, down last. And that's it. These questions are from a previous lesson, so that's all for transformation. So pretty basic, follow the same rules we've always used, and you should have no troubles.